In this video, we will be demonstrating Contrail service orchestration with public key infrastructure. In the first part of the video, we will be enabling a simple PKI infrastructure based on Windows 2012 server. In the second part of the video, we will be onboarding a tenant with two sites. One of the sites will be a Cloud Hub site, and the other site will be a Spoke site, using CSO with PKI. So let me show you the end state. In the end state, we have IPSec tunnels between the two sites. The question is how IPsec tunnels or how these devices authenticate each other. One way is pre-shared keys, the other way is digital certificates. In this video, we will be demonstrating CSO with PKI, meaning we are using digital certificates. Obviously, for that, we need to have some kind of PKI infrastructure. The simplest possible that we can find probably is based on Windows 2012 server. That server will be running two services. One is Certificate Authority, the other is Network Device Enrollment Service. All these acronyms will become clear later on while we are going through the video. So basically, what is important from this diagram to acknowledge is that CSO will be a SCEP client. SCEP is Simple Certification Enrollment Protocol. That protocol serves the purpose of managing certificates, and all the messages that are involved, for example, in this basic workflow happens thanks to SCEP protocol. So CSO is the client, Windows Server is the server. So what happens here, there is no assumptions that end devices have access to the SA, to the CA. That means that everything certificate related needs to happen on CSO. CSO will be generating the keys. It will also issuing certificate signing requests, receiving certificates back from the CA, and then during the different phases of onboarding of these devices, it will be pushing those keys and the certificates onto the devices. So devices are not the clients at the moment. They're not the clients of the CA, of the NDES. So we will be observing this basic workflow during the onboarding of the devices and onboarding of a tenant. We also need to acknowledge that CSO, that the whole certificate enrollment happens per tenant. So tenant is the entity that owns certificates. Then devices and devices are part of the tenant realm. So in theory, even different tenants could use different certification authorities. So that is another thing that we need to acknowledge. So having said that, let's just quickly, before we start, refresh our knowledge or why we and where we are actually in this whole IPsec hierarchy. So before IPsec tunnels can spring to life, first internet key exchange need to happen, and during that phase, the peers need to authenticate each other. So there are two ways how they can do that: pre-shared keys or digital certificates. We will be observing the second one, so PKI infrastructure that will be a provider for digital certificates. Also, I'm representing only two sites, but imagine that we have several hundred of devices or thousands of devices, then obviously authentication based on certificates is more scalable. This is what happens during the IKey phase. And the whole purpose of the public key infrastructure is, among other things that it's serving its purpose for, one of the purposes is to manage certificates for specifically IPsec VPN environments. That's one of the purposes of public key infrastructure. So having said all that, let's start with building PKI infrastructure. First thing that we need to do is to enable PKI, public key infrastructure. In our case, PKI will be comprised of one Windows 2012 R2 server that will run two services: Certification Authority Service in standalone mode and Network Device Enrollment Service. So before we start configuring the server, let's quickly revisit certain acronyms and entities that are going to be involved in issuance of digital certificates and distribution of those. So as the name suggests, the certificate authority is the entity that issues digital certificates. The network device enrollment service, don't forget we are enabling CA plus NDES on the same Windows server, is one of the role services of the Active Directory Certificate Services role. NDES implements the simple certificate enrollment protocol. This protocol has been around for a long time. It's in draft version as an RFC. So this is the thing that enables distribution and enrollment of certificates between end devices and the CA. So we can think of NDES as a Microsoft specific implementation of this particular protocol. So simple certificate enrollment protocol defines the communication between clients. In our case, this will be CSO and a registration authority. Again, in the white paper that Microsoft published for this service, we will see that they refer to NDES as a registration authority. And enrollment is the process of obtaining a new certificate from a certificate authority. So basically, this is like in a few seconds, all what you need to know about PKI. Obviously, PKI gets very quickly super involved. So having said that, let's start with a configuration of Windows Server to enable these two services, CA and NDES. So we are going, first of all, we are going to leave everything on default. This is minimal configuration. We are not interested in security aspects of a particular PKI solution. We are more interested in the workflow. So basically, let's start enabling CA and NDES. So start Server Manager, add roles and features, leaving everything as per default, add features, next. We need two services. All of these services have certain dependencies. One of the dependencies is Internet Information Services, which is a Microsoft web server. Add features. So we've got Certificate Authority and NDS that we are going to enable with all the dependencies that these guys require. Next, next. Restart. Yes, this is basically a test environment, and install. While this is happening, it takes like a minute or two for this to finish. Let me show you the article that I was following for this. By the way, Internet Explorer Enhanced Security Configuration is not enabled. Yes, this is what we want. Otherwise, we would require to have like 100 clicks for every page that we want to open. So I suggest you disable this basically under Server Manager. Let me see if I can see local server. And this is what I'm talking about. Internet Explorer Enhanced Security Configuration currently is off. By default, it is on. So I suggest you turn this to off. Okay, so this is the article I was telling you about. Microsoft TechNet, this is a white paper on Active Directory Certificate Services and Network Device Enrollment Service. So the article is very good. It's all encompassing. Many things are explained nicely in a simple way, actually, for a layman user. So I suggest you read it. What we are interested in is, so let me just point certain things that we need to change. Standalone. First of all, deployment scenarios, we are doing standalone scenario deployment. So we will have network device enrollment service and standalone CA on the same box, one Windows server without Active Directory. That would be another implementation. The other thing that we need to look, actually, let's look a few more things for standalone. It says here for standalone CA, the default issuance policy is to hold all certificate requests for approval by a CA manager. We need to change this. We want automatic issuance of certificates without a CA manager involvement. So this is something we will have to change once the service is up and active. And the other thing that I want to point your attention to is password. Remember that field when we were onboarding a client, it asks for two fields to be populated if we are going to use PKI. One field is a particular URL. We will talk about this URL very soon. The other thing is a password field. So when it comes to passwords, this password turns to be one-time password and it's quite restrictive. We need to relax this criteria a little bit so that one password doesn't change and we can reuse it across multiple devices. To do this, we are going to follow these steps. So it says here, in some environments, it may be desirable to reuse the same challenge for more than one device. So this is what we want to achieve. Okay, having said that, let's get back and see where we are with a services installation. It says configuration required, installation succeeded. All right, so let's go here and configure Active Directory certificate services. Right, so as we said, we are going to leave everything per default. First, we start with certification authority. Next, standalone, that's the one that we are using. Root CA, next, next, not interested in security aspects, next, 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 and configure. Configuration succeeded, fine. Do we want to configure additional role services? Yes, the one that we need basically is network device enrollment service. Let's configure that one. Again, here specify the service account. We are going to use the built-in application pool identity. You can read about this. It's a security feature, makes life easy. So let's use that one. Next, and configure. Okay, by doing this, we should now have NDES plus CA active on this machine. To check this that quickly, let's open another tab. And I was telling you about certain URLs. So the URL that provides us with the password is this one. So this is the IP address of the machine where we have these services. And under this particular URL, we see that we get a certain password. This is the password that we are going to enter in that field under when we onboard a tenant, so the second field. It says this password can be used only once and will expire within 60 minutes. This is what we don't want. We want to be able to reuse the password. So we will have now to change something in registration keys to enable actually password not to change. So if I go back and revisit this article, these are the steps what we need to change. So the first step is set this keyword to 0 to 1, from 0 to 1, and let me do that. Okay, we are at the right place, looking for software, Microsoft, and it's cryptography. MSCEP is the service that we are interested in. Use single password. This is what we want. So it says change this to 1. I think that is what this guy is saying. So it says configure service to function in a single password mode by creating a value using single password and setting it to hexadecimal 1. Okay, setting it to hexadecimal 1. Okay. For this to work, we also need to basically restart SCP's service. So it says here, in the advanced settings dialog box under process model configure, load user profile to true, click OK. In application, pulse, right click system, and then click stop, and then click start. Okay, so that thing is here, server manager, tools, internet information services. Go here, application pools, simple certification enrollment protocol. Okay, go to advanced settings, and it says change load user profile. Change this to true. Okay, and stop and start application pools. Okay, so that's done. Let's see how this reflects on the password change. So let's refresh the screen. And we see the enrollment challenge password is this one, and now it changes. This password can be used multiple times and will not expire. So indeed, if we refresh this on several times, we see that the password doesn't change. That's good. The second thing, by the way, there is one more thing. If you don't change these settings, that is what I noticed. If you don't change these settings under Internet Explorer, Internet Options, Security for Internet and local intranet, make sure that you have automatic logon with current username and password. If you don't have that, then it will ask you every time you want to access this page, it will ask you for a password. So just make sure that on both of these guys under custom level, you have automatic logon with current user and password. Okay, so this is the page that provides us with the password. We are going to enter this password in the second field when we onboard the tenant. One more thing that needs to be done, as I mentioned, is in the article is saying with standalone guy. So stand alone. So let me find. For a standalone CA, the default issuance policy is to hold all certificate requests for approval by CA manager. So we want to avoid this. We want actually automatic issuance of certificates. So to do that, let's quickly enable this under the policy. So again, server manager, tools, certification authority. Let's look at the properties. Go to policy module, properties, and it says here, set the certificate request status to pending. No, we don't want this. We want the second one. If applicable, so otherwise automatically issue the certificate. So use the second one, apply. Active Directory certificate service must be restarted. Okay, let's do that. Okay, and here, all tasks, stop service and start service. While we are on this page, let's see the issued certificates. So currently there are two default issued certificates. And again, if you go back to this article, certificates, we see that service, this particular NDES service has two default certificates that get configured automatically. These two guys, let me show. So these two guys will be used together with a CA root certificate for device certificate enrollment. So basically with this, we have configured our Windows Server to provide CA and NDES service to its clients. In the second part of the video, we will see how device enrollment happens in the case of a CSO and uh, who is doing what in this particular scenario. In the second part of the video, we are going to observe workflow when it comes to device enrollment. So we will first start with tenant onboarding. We are going to onboard a tenant now. So we are at CSO administration portal. Um, let's start by adding the tenant names, like tenant PKI, for example, and like some username. Um, let's define user role. That's fine. We need to select topology. Let's use full mesh, for example. And the important part is here. Under VPN authentication, we have two options. One is pre-shared key, the other is PKI certificate. We are going to choose PKI certificate. So here we are presented with two new fields. One is for CA server URL. That server URL needs to be the following. So let me paste this URL. This is the IP address of our CA server. And for the password, we will enter the password that we have played with previously. So let us actually check here. So this is the password called the Enrollment Challenge password. So let's select. Okay, that looks good. We're not going to change. Yeah, let's do this. This is by default because we have chosen full mesh. Other things are optional. If we are happy with the details, we can proceed and click OK. So now we are going quickly to observe on Wireshark that we have started on the CA server. We want to see messages being exchanged between the CA and the CSO. So we already see that TCP authentication between the two devices, CSO and the server, took place, and some messages are exchanged. So we see that CSO sent via simple certification of the enrollment protocol this message, and as a return, it got the following message. So now if you want exactly to see what these messages are, then we open the draft of the simple certificate enrollment protocol, and then we exactly know what the messages represent. No certification has been issued at this point in time. So you see, if I click here, we just have our two default certificates. But what happened is CSO has now received, let me show you that. So CSO has now received a CA chain. So that means under this particular tenant that has been just onboarded, CSO received 3 certificates. So the 2 that we have shown before, and also the CA root certificate. So using those 3 certificates, in the next step, when CSO issues request for certificate signing request, all these 3 certificates will be used. So we are not going to go into details of how each certificate is being used. We just need to be aware that CSO has received and installed this chain. So step number 1 is done now. And also the important thing to notice is that PKI is done per tenant. So in theory, each tenant could have different certification authority. So PKI is done by the tenant. So onboarding of the tenant is finished, and we can now proceed to add a Cloud Hub. After we have onboarded a tenant, we are going to add a hub to the tenant. So let's see what happens in this case. Okay, after adding a tenant, let's add a hub to that tenant. So here's the thing, Cloud Hub is a shared resource. That means that many tenants can share one hub. So when it comes to certificate distribution, hub will get its keys and certificates from CSO once it's added to the tenant, not before. So, but just before, I have three hubs here. They have been currently under global level. They're cloud hubs. They are going to be shared. So just before we go under the tenant level, let me just show you where you need to select value for the authentication type. So basically on the page where when you are adding a hub, there is a authentication type field, and here's where would you select that you want public key infrastructure. So this still has nothing to do with the tenant at the moment. This is just as a global resource when we are provisioning the hub. And using that method, we have provisioned one of these hubs to use a PKI infrastructure. So now let's go under the tenant level, and under sites, we still see that we don't have any sites here. So I'm going to add a Cloud Hub site. So at this point in time, when I click here OK, after I enter the values, that is when CSO is going to basically generate the keys and also to ask the CA to sign the certificate. So let's give it a name, Hub 4, Cloud Hub. We are going to skip all the fields that are not important. The hub that we are interested in is under POP 4. So this is Hub 4. Here, from the last time when we were onboarding the tenant, we saw some exchanges between CSO and the CA. I'm going to clear that screen now. And we are going back here, and we are going to click OK and see what happens. Okay, we are still monitoring the Wireshark. We want to see the exchange of information between the CA and CSO. Don't forget that CSO is the one who generates the keys and the certificates on behalf of the end devices. So here's where exchange happened. This time we have another message here that CSO has requested from another operation, PKI operation, that CSO has requested from the CA, and we got a response. So in this response, we are receiving a signed certificate. So let's confirm that by refreshing here the CA output, and we see the CA has generated one more certificate. Let us open that certificate, and indeed this is a certificate for Hub 4 under tenant PKI. So to basically confirm that something happened, let me just check that this process is done. This job actually has been yeah, the job has been done, and even we can see that installation of certificate happened. So let me just use my presentation here. So what happened in this case, we are now at the step number 2. So CSO has generated the keys and also generated a certificate signing request. Once it received response from the CA, it then pushed the whole thing, the keys and the certificate onto the hub through a SSH channel. Because hub is not involved in ZTP, there is a secure channel, SSH channel between CSO and the SRX, and all the certificate and keys have been distributed from the CSO now to this cloud hub. Okay, so let's log on to the hub and see the situation. So before, you can see that I was looking for a CA certificate and I was looking for the local certificate, and now I should expect to receive to see actually the certificates are there. So let's start with a local certificate. Yes, indeed, local certificate has been pushed from CSO, not from the CA, but from CSO. That is very important to distinguish. So let's just check that this is the right certificate, not brief, but detail. Let's see what it says here. So if we look at the serial number of the certificate, so 4B00 and 07 at the end. So here, what do we have? We have a serial number, details, and serial number, which is 4B and at the end 07. So indeed, that's the certificate now, that is local certificate for the hub, and has been pushed by CSO. So that's good. The other thing that we want to check is a CA certificate. So detail as well. And we have a certificate identifier. This is our server IP address. And the certificate serial number is 63518. This is basically a CA certificate that Hub needs to have in order to be able to later on authenticate other devices that want to establish IPSec tunnels with it. So this is a CA certificate, 634518. Let's just basically check under certification path. This is a local certificate of the hub, but if you look here, there is now a little chain, and this is a CA root certificate. So let's look at that one. Details, serial number 634518, and here is 634518. So indeed, hub now have two certificates, one local and the other from the CA authority. Also, under the tenant PKI, if we go into to look under administration, we have certificate management here, and we can see that two certificates have been installed. One is the root CA. One is the tenant certificate, one is the hub certificate, and the other is the root CA certificate. So that concludes enrollment of the hub to the for the certification to the CA. After we have onboarded the hub, it's time now to onboard a spoke device. So spoke device will be NFX 250. This device will go through ZTP process, unlike the hub. Basically, via the ZTP process, VSRX gateway router will be spawned. It is gateway router that establishes the IPsec tunnel connections. When it comes to generation of the keys and device enrollment, that is all delegated to CSO as before. So CSO is the entity that communicates with the CA server. So CSO will generate the keys, it will enroll this device, and then during the onboarding process, it will, through secure HTTPS channel, transfer the keys and certificates onto JDM, which is part of NFX 250, until the time comes that gateway router is spawned, and then it will load those certificates from JDM to the gateway router. Once that's done, IPSec tunnels will be established, as those two devices will be able to authenticate themselves through the means of digital certificates. So let's get started. Okay, now we will be adding a spoke site. So on my diagram, we are going to provision a NFX 250 device as a spoke device. So I have already added that site. Configuration is ready. I just need to click OK here just to speed up things a little bit. So I'm now adding a configuration for the site, and here we are going to clear again the Wireshark so we can observe what happens, what kind of exchange will happen between CSO and the CA. So this will take a little bit of time. So we should expect here to see another certificate being generated. Now we have 237. We should expect number 8. We can also observe the current progress. Configuration of the site is in progress, so we can see what's happening here. During this phase, CSO will generate the keys and create a request for certificate signing request to CA. So this is all happening before this site goes into ZTP. That's very important to stress. So as per before, CSO generates everything certificate related, and then during the ZTP, certificate will be moved from JDM to the gateway router. So I'll explain a little bit more how that happens, over which channel. Still, the exchange didn't happen between CSO and the CA. So let's wait a little bit. Currently, the site is being configured. Configuration is in progress. Let's monitor to see what happens here. We should expect very soon to see exchange of information between the CA and CSO. Let me see if I can reduce the CSO window so that we can observe this job while it's in progress. So this job basically is about configuring the site. a number of links, virtual links is being created. Actually, this NFX15 site is the one that has four physical links. So it's gonna be a little while until this job is done. Okay, here's the exchange of information. It just happened. We can remove this. So again, CSO has generated the keys and uh, request for signing of the certificate, and CA has responded back with basically with the signed certificate. So let's refresh this. We see that certificate number 8 has appeared here. Let's quickly open it. And indeed, this is a certificate for NFX 15. That's the device that we are configuring. So now what we need to do, we just need to wait until this job is done. It's still in progress. I will stop video here. Then I'll continue at the point where ZTP is in progress. Okay, I have activated ZTP on this device. ZTP is currently in progress. Before ZTP, bootstrap phase happened. And during that bootstrap phase, the certificate has been transferred from CSO onto JDM. So in the var third party CSP directory, we have directory called PKI. If we go into that directory and see, we will see that certificates and the keys have been transferred to the JDM. What is happening now is that we need to wait for gateway router to be spawned, because the gateway router is the one to establish secured IPSec connections to the hub, and for that IPSec tunnel to spring to life, certificates and keys and everything needs to move from JDM to the gateway router. So in this phase now, we are waiting for gateway router to be up so that certificates can be loaded onto the gateway router. Once that's done, that will be precondition for OAM IPsec tunnel to become active between VSRX and SRX. During the bootstrap phase, the keys and certificates have been transferred to JDM through the HTTPS channel. And then during the ZTP, once gateway router comes up, the keys and certificates will be transferred to gateway router, and they will get deleted from the JDM. So now what we need to do, we just need to wait for the gateway router to spring to life and see basically whether IPsec tunnels come up. So I'll stop this video and continue once the ZTP for NFX 15 is done. The ZTP job for NFX 15 has finished. So if we log now to this site, actually, let's first see how this looks like under the site level. tenant PKI. So we have here two sites, Hub 4 that we added before. Now we have you can see that NFX 15 site has been provisioned. Let's see, show virtual network functions. VSRX has been spawned. Let's log on to the gateway router. So the gateway router is the one that will hold certificates. So certificates during ZTP will be moved or loaded from JDM onto the gateway router, as the gateway router is the one that establishes IPSec tunnels. So show security PKI local certificate detail. So here is the local certificate. Let's just confirm that this is the same certificate that has been generated by the CA. So if we look at the serial number, it's 4B and ends with 08. So here we see it's 4B ending in 08. That's good. And also gateway routers should have a CA certificate, root certificate. So show security PKI question mark. So CA certificate, CA profile, and the profile that we are interested in is this one that comes from our CA authority. So let's check that one. Again, it's 63418. Let's quickly confirm that's the root certificate, 634518. So that's good. Gateway router holds, it's got its own local certificate that's been signed by the CA, and also it holds the CA root certificate. So basically, let's see the status of the security associations. And we see that the number of tunnels are established currently between the hub and NFX 16. We can confirm that on the hub side as well. So this confirms basically that generation of certificate, or to be more precise, enrollment of devices and certificates has been successful. CSO has successfully actually generated certificate signing requests on behalf of both devices, VSRX and SRX. So there is one more a workflow that we can probably quickly check. For example, if you go under the tenant PKI, let's just confirm here basically under certificate management what we have. So we can see that two certificates are there for Hub 4 and also for NFX 15. And let's, for example, let's try to renew the certificate. But before we do that, we see that number 8 here is the last one. So let's see what happens when we issue a renew request. Actually, what I should have done, I should have probably cleared this. So let me actually clear this, continue without saving. So certificate number 9 has been issued. Um, so let's do this one more time. I just want to see here, although the certificate had been just issued like 1 minute ago, what I'm going to do, I'm gonna renew this one more time because I just want to see the exchange of information here that we seem to have missed. So again, renew the certificate. Okay, we see the exchange information for renewing. Refresh, certificate number 10 has been issued. So for NFX 15, let's just check the serial number. It's 4B and 0A. So on NFX 15, show security IPSec, show security PKI, local certificate, detail, and serial number 4B00A, 4B00A. So at the time of making this video, CSO is at version 402. Certain workflows and PKI infrastructure is going to be improved in next releases. Currently, we can renew certificates manually, but in the next release, auto re-enrollment will be happening based on the timings and expiration of certificates. So this concludes our story on, or CSO story on PKI infrastructure. And so see you in next video. Thank you for watching.